I like solving problems. If there's a problem to be solved, I've always gravitated towards figuring it out. And it all started with when I watched a video on the tail of two mice that talked about how they were genetically susceptible to various diseases, and yet they didn't get them because they were provided methylated nutrients. And yet the genetically identical mice that didn't get those methylated nutrients went on to have diseases. And I was like, wow, really? That's pretty
Incredible.
Phenomenal. Yeah. And so I was like, well, what's that have to do with what is methylation and all that? And I didn't really know. I mean, I knew it was folate and B12 and homocysteine. I knew the basics. And then it was probably a year or two later that it was maybe even longer, where I was doing some research on bipolar disease. And this acronym popped up in National Library of Medicine, PubMed, and it's talking about how people with bipolar struggle with folate metabolism and MTHFR. It's like, well, what the heck is MTHFR? I had no idea. So I put MTHFR back into the PubMed search, and all these hits came back about MTHFR cardiovascular disease, MTHFR preeclampsia, MTHFR infertility, MTHFR breast cancer, MTHFR cardiovascular disease. I was like, oh my God, how did I not learn about this? And I still didn't know what it was. I just knew what it was associated with.
Yeah.
And then I realized, it's like, wow, I thought folic acid was fine, but apparently it's not. So that's I put myself in a big rabbit hole, and I have been enjoying the journey ever since.
It's definitely a huge rabbit hole, and you do such a great job of making sense of all this. So maybe we can start out with talking about folic acid, because most people think of folic acid as a healthy vitamin, something that's important in pregnancy and protecting perhaps against birth defects. So can you speak to perhaps the initial uses of folic acid in the 1980s, bring it into the food supply, and then what we know about it today?
Yeah, great. It's back in the day, our ancestors would go around and they would eat leafy green vegetables, and they would eat liver from the foods that, from the animals that they hunted and got and prepared. So naturally their folate was provided for. And the term folate, if you think about it, folate, foliage, it's the same thing. So foliage is green, folate is found in leafy green veggies, and so they were naturally going around and getting it. And that was all fine until the industrialized folks came around and said, you know what? We're throwing bread on the shelves, and, because grains, were originally plants at first before they became grains. And they started putting fresh breads on the shelves, and they would sell out and say, well, how do we make this better? So then they've produced a bunch of bread, but then they wouldn't sell it, and they'd have to throw it all away because it wasn't shelf stable. So they said, okay, well, they researched into this, and they decided to strip all the nutrition on basically the protein and all the good stuff off the grain, and it was left with a flour. It was basically dead material, and they used and created breads with that. And lo and behold, that stuff could sit on the shelves for a lot longer, and so off it went. And everything was great.
Progress,
businesses
right?
Yeah, progress. Yeah, success. And later, there's like, wow, there's a lot of birth defects going on. There's a lot of issues going, cardiovascular or congenital heart defects and congenital birth defects and preeclampsia and miscarriages and infertility. And I'm like, what the heck? And neural tube defects. And then they traced it back to, it's like, gosh, you know what? This flour is nutritional garbage. There's nothing in it. So the solution wasn't, oh, God, we did a bad thing. We'll go back to whole grains. And, folks, you just have to buy the bread when you need to buy the bread, and we won't produce as much. No, they synthesized a nutrient which looks close to natural folate, but it's very, very importantly different. And the difference is substantial. And that folic acid does help some people. So they synthesized a synthetic type of folate, threw it in the bread. Neural tube defects did go down. Infertility did go down. All these things went down, but only in select populations, not all of them. Some people, not all of them. It didn't fix the problem. And nobody talks about that. Nobody talks about that, wow, they introduced folic acid and no one's getting neural tube defects anymore, and no one's getting these issues anymore, despite taking folic acid. And to me, that deserved a further looking into, because again, I like solving problems.
And for folks listening in, kind of that difference between folic acid and dietary folate, can you really hammer that home for folks?
Yeah, great point. So folic acid, it's composed of 3 components, and I don't remember what they are. It's like pteroglutamic acid and glutamate and something else. But what's missing from folic acid is a methyl group. What's missing from folic acid is a methyl group. And to put that methyl group onto folic acid requires multiple steps. In fact, I'm looking at a pathway here on my nerdy poster that I drew out. And then there's 1, 2, 3, 4, 5, 6 enzymes. And enzymes are produced from genes. There's 6 enzymes that are required to transform synthetic folic acid into the body's number 1 primary form of folate, which is called methylfolate. So folic acid isn't methylated. The body's primary form of folate is methylfolate. To put that methyl group onto folic acid requires 7 different enzymes, and a lot of those happen to be difficult to put that methyl group on there because they're not working quite right because of genetic variations from our ancestors for various reasons.
So, yeah, maybe this is a great time to jump in, and you did present, I'll actually include it in the show notes here, that wonderful biochemical pathway so we can get a sense of those enzymes. But perhaps maybe a great time to talk about SNPs and what some of those defects are in those pathways that people might have.
Yeah. So, when I first looked into SNPs, like MTHFR was my first one, and you read the research about how it's associated with all these conditions, negative conditions, right? Preeclampsia, infertility, breast cancer. You immediately associate MTHFR SNPs as bad. And first of all, we have to define a SNP. And a SNP is genes are made up of long amounts of basically DNA bases, right? So there's these bases of amino acids, and thymine, adenine, guanosine, so on, cytosine, and they're linked together. And as they're linked together in various organized fashion, they produce the gene. And so some genes can be thousands of these long, some of them can be tens of thousands long. And when one of those base changes are different, that's called a SNP, a single nucleotide polymorphism. So those bases, those amino acid bases, are called nucleotides. And so when one of them switch, it can alter the function. Now, we have to keep in mind that these SNPs can be deleterious. I'm just going to say bad.
Yeah, for sure.
That's a hard word for me to say. So they can just not be beneficial to us at first look, right? They've altered their function. They've either sped it up or slowed it down. And so a SNP is different than, well, let me back up for a second. Genes can be very, very common in the population. A certain gene like MTHFR, the majority of the people have a MTHFR gene that has a cytosine nucleotide. However, 50% of Italians and Mexicans and the Chinese have that cytosine nucleotide switched to a thymine. And that thymine is where that problem happens, that shift. So it's just that one nucleotide that shifted from a cytosine to a thymidine, and that's causing all this hoopla about MTHFR. And yeah, I got on the bandwagon, and it's that what it did is it altered its function by about 30% or so. It slowed it down. It didn't make as much methylfolate, and so that's what SNPs can do. They alter the speeds of genes.
Gotcha. So like someone taking or not taking their coffee in the morning, so to speak.
Mm-hmm.
In terms of that speed idea of the genes working quickly.
Yeah, or taking too much coffee. So The MTHFR gene, for example, works too slowly if one has a MTHFR SNP. And yet there's other genes like superoxide dismutase, which is very, very important for eliminating superoxide, which is a very potent free radical. This gene is a SNP that makes it really fast. So there's depends on the variation.
Gotcha. Now, what are some of the implications? Because I know in the initial stages, it was worrying about the types of SNPs that we had, and you mentioned in your talk, obviously at AHS and all your work around, this idea of good and bad and being sort of oversimplistic. But what are some potential, perhaps, symptoms or issues that might come up if someone has, too slow or too quick in terms of the MTHFR?
Well, it's if someone's MTHFR gene is working slowly, well, their enzyme, because their MTHFR gene produces a enzyme that isn't very fast. And so compared to the preschool that do not have the MTHFR SNP. And so if someone has an MTHFR SNP, their ability to produce methylfolate goes down, right? But yet they still can produce it. They still have say if they have one SNP, they inherited, say, one SNP from their dad of MTHFR, and from their mother, they inherited a good MTHFR. There's no SNP present. So one variant or one SNP can slow their ability to produce methylfolate down by about 20 to 40%. And if you get one copy from each of your parents, then you can get two SNPs and you can slow your MTHFR function down by anywhere from 40% down to about 75%. So it's very significant, but you still have anywhere from 40% left to 25% left capacity. So that means if you have a battery and you want to run, say, a flashlight outside, you have only 25% time for that battery before it runs out. You can still get stuff done. It's just going to run out quicker, and you need to recharge it faster. If you have a solar-powered battery, then you can stay out there longer. Now, someone who has a regular MTHFR, they've got a full battery, and they can go out and do things longer. And now why I said all that is because MTHFR produces methylfolate, and methylfolate it supports your methylation system, and methylation goes and produces a bunch of very, very important components in your body, like cell membranes and so on. So if the MTHFR gene isn't working very well, and it's slow, then your ability to make the body's number one form of folate is reduced. However, the beautiful thing is you can get your methylfolate from your leafy green vegetables, and you can get it from liver. So even if you have an MTHFR SNP, you're still getting it from your diet, especially if you're eating an ancestral one.
That becomes important then to ensure, the solid nutritional foundation there of getting the leafy greens in, getting some of the organ meats to meet those requirements, even if you do have SNPs, as you mentioned. Now, what if somebody is, say, having the standard American diet, not eating a lot of leafy greens or organ meats? What are some potential issues that would arise from having, some of these SNPs for MTHFR?
Well, you would be like what happened to me. I've got MTHFR. I have two significant SNPs. My MTHFR enzymatic function is reduced by 75%. I have only 25% functioning, basically. And I did not like salad. I was eating the typical carb, high-protein diet. I was an athlete. I was competing hard. And I would get exhausted quickly. I could not tolerate alcohol really at all. And I had high blood pressure already when I was a older teenager. So when I was 19 years old, my blood pressure was already 150 over about 90. I almost didn't make the rowing team. And they said, "Wow, that's really high. Why is your blood pressure so high?" And I wasn't nervous, and I was pretty fit already. And it was alarming to me as a 19-year-old to have a blood pressure of 150 over 90. So it just shows you that my environment, that I also was raised on a horse ranch where there was a bunch of chemicals sprayed around. So, I sprayed Roundup like it was water, and there was crop dusters all over, flying over our homes too, to spray the neighboring fields of a few hundred acres of mint or potatoes or what have you.
Gotcha.
And So I was a living 19-year-old already with high blood pressure, very high post workout fatigue and soreness. It took me a long time to recover, way longer than my other teammates did. I could not gain muscle, no matter how much I ate. And it wasn't leafy greens or organ meats. It was protein and carbs. Didn't matter how much I ate. I could not bulk up. It's because methylation, which is what your MTHFR gene supports, helps to produce creatine. So I was not able to make sufficient creatine. So hypertension.
Pretty darn important for athletic performance.
Yeah, exactly. And I wish I knew this then. So my muscle mass was down. I had hypertension. I was fatigued. Those are very common ones. My cognition, my ability to think and contemplate and reason and problem solve was also reduced. I was not doing as well in school as I should have, and I slept a lot, and my morning fatigue was really high. So it was a problem. I was embarrassed actually, and I didn't understand why I was so tired. And this is how a lot of people feel when they have it. And then they also have infertility. Which is actually good when you're a male college student. And then and when you are pregnant, you run the risk of having miscarriages or problems with your pregnancy, like preeclampsia, hypertension, and so on. So it's a very serious deal.
Absolutely. And can you speak to people who do need perhaps more support? The different forms of supplementation and how looking for the different forms of folate would be the most obviously beneficial for them.
Yeah. So, for example, I love supplementation. I mean, I own a supplement company, but I still really want people to understand how genes work and why they're doing what they're doing. And the basic premise that we have to think about first prior to supplementing is to understand that supplement means to add or enhance. And a supplement's job is to add or enhance our physiology and our biochemistry. And you boil that down even further, supplement's job is to support our genetics, right? I mean, think of it 100%. As a nutshell. So if you are working your genes hard, if you are, if you're working on your business and you're just grinding at it, then you're working your genes hard. If you're on vacation, if you're just going for walks instead of preparing for triathlons or long bike races or trying to bulk up, then you probably don't need so much support. Your genes aren't working as hard. So every day I want people evaluating, how hard are my genes working? And if they're working hard, then diet alone and sleep alone might not be sufficient. You might need additional supplementation. Where people get into trouble is if they go on vacation or they're not working very hard that particular day and they supplement with various types of folate, like methylfolate, for example, then they get anxious and irritable. And then they say, oh, this is bad for me. It's like, no, you didn't need it. You had enough. Your MTHFR gene didn't need to go to work. Now, if you drank a bunch of alcohol and you partied hard, then yeah, you need more methylfolate for that. So understand that genes do work, and how hard you're working them dictates how much supplementation that you need beyond your natural healthy lifestyle, diet, and environment. And so that's what I like to say first about that. And your specific question, Mark, was, what are the different types of folate out there?
Yep.
Yeah. So sometimes my answers get long-winded because I have the very important preface I have to
No, I mean,
state.
that's a great point. I think a lot of people don't think about dosing and things like that when they think of supplements. They often just think of solutions as a quick fix or whatnot. So I think that's a great emphasis there.
Yeah, a lot of people too is you'll have a stash of supplements in your cabinet, and when you get that stash of supplements, you learn that this one's good. You learn that one's good, and that one's good, and then pretty soon you got 10 to 15 supplements on your counter, and you take them every day because they're all good, and yet your genes now are getting all this massive support from your supplements, and they're like, dude, stop already. I don't need all this stuff. It's like insulin resistance. You've already got enough fuel in your cells. Stop giving me more supplementation. So now let's say you had some alcohol. Let's say you are lifting weights. So there's different types of folate. There's three main ones that are commercially available. There's folic acid, which you should never, ever use. And that's extremely controversial. And you will hear it from many, many experts out there that will say that I'm wrong. And you'll hear from me that's telling them they're wrong. So you're going to have to just kind of pick which camp you're in and go from there. So I'll preface with that.
Yep.
And I'll also say that our ancestors had no access to folic acid at all. So our ancestors from hundreds of thousands plus years ago had no access to folic acid, period, ever.
Yeah, it's at 99.9999% of our time here on the planet.
Yeah, exactly. So we made it this far without folic acid. So I think we're doing okay if we don't supplement with folic acid. So folic acid is one of the three types. You just don't take it. The second type is methylfolate, the one that we've been talking about. And there's another one called folinic acid. You're like, well, what's that? I rarely hear of folinic acid. So there's a drug called leucovorin, and that's the drug name for folinic acid. And you can spend more money if you want to get leucovorin and get all the fillers and food coloring and dyes and what have you with leucovorin. Or you could just buy a very inexpensive, like $7, $8, $9, $10 bottle of folinic acid over the counter. And they're typically available in 800 micrograms. The RDA dose is 400 micrograms of folate a day, which I think is kind of borderline low, but again, it depends on what you're doing, if you're drinking or exercising or so on. But let's talk about first what these types of folates do, shall we? Because they do different things.
Absolutely.
So methylfolate supports methylation. So if you have high homocysteine, or you want to make more creatine because you're trying to bulk up, or your cell membranes, you order a lab test and you find out that your lipid peroxides are high, or your DNA adducts are high, your oxidative stress is high, methylfolate is what you want to be tag teaming with. You want that in your corner. So homocysteine elevated, methylfolate. You want to support methylation, you want methylfolate. If you're trying to, again, bulk up, exercise performance, if you're drinking alcohol, methylfolate is what you want. If you're exposed to laughing gas, nitrous oxide, nitrous oxide wrecks your vitamin B12. It destroys your vitamin B12. It oxidizes it. Nobody talks about oxidized B12, but that's what happens. And when your B12 gets damaged, your methylation gets screwed up. So if you're ever using laughing gas, and people are now using it as a drug, they're getting access to it and using it for fun. It's like smelling paint,
Yep.
The things that people do.
Exactly. Exactly.
So methylfolate's good for that too. Now, folinic acid is fantastic when you're on medications like methotrexate or 5-FU. And the reason is because methotrexate blocks the gene which processes folic acid. Most doctors will prescribe folic acid to people who are taking methotrexate. And that's the stupidest thing in the world. It's like driving a car with 2 feet, one on the gas and one on the brake. It's the same thing. So they're inhibiting this one particular gene. It's called DHFR for those people who want to dig into it. Doesn't matter though. Methotrexate inhibits this one gene, so it can't do work. And if it can't do work, then these people get platelet deficient. So they start having bleeding problems. Their white blood cells go down. They can't fight infections. Their hair falls out. They become anemic. So all these things happen, and it's because they're becoming deficient in folate. The problem is doctors say, here's folic acid, but the methotrexate is blocking that gene's ability to process the folic acid. So it's pretty dumb. So you use folinic acid. So if you're not on methotrexate, you can think back, well, he just said that if my hair is falling out. Yeah. So if your hair isn't growing very well, if your hair is falling out, if you're anemic, if your white blood cells are low, you're not able to fight infections, if your platelets are not forming and you're bleeding, too much without it stopping, that's where folinic acid comes into play. Also, if you get sunburn is also what you want because it's DNA repair. And if you want more energy, folinic acid is useful for that too. If you want more neurotransmitters, you want also folinic acid. So folinic acid is really, really lost in the limelight of methylfolate. And I'm partially to blame for that because I didn't realize how important folinic acid was. And methylfolate can turn into folinic acid, but again, it requires a lot of multiple steps for that to happen. And to give you an example of how this works was I had a doctor email me and they said, look, Ben, I hear you. I'm not going to use folic acid ever, but I got this patient on chemo and their hair's falling out. I gave them methylfolate and their hair's not coming back. So what do I do? Do I give them folic acid? And I was like, no, you give them folinic acid. And they said, well, why? I said, well, because hair is protein and hair requires DNA. Folinic acid supports DNA-based synthesis, and the methylfolate isn't working for them because their methylation cycle is all damaged because of low glutathione and heavy metals from the chemo. So the methylfolate's stuck. It can't get used to come around and support them. So you have to give folinic acid directly. And here I was. This is the first email I ever got, nice. And I was just following the principles, right, that I learned from the biochemistry books and my pathways that I drew. And she emailed me a month later. She goes, "It worked." I was like, "Oh, thank God!"
Fantastic.
So, but yeah, folinic acid's fantastic too.
And if we talk delivery methods, there's capsules, lozenges, things, slow release versus liposomes. Can you speak to that in terms of scenarios where one might be better over the other?
Yeah, great point. Thanks for bringing that up. So let's start with the most commonly seen over the counter, and that's tablets. So tablets are very easy and very inexpensive to make for supplement companies. And I don't know if you've ever been into a supplement manufacturer. I've been to many of them, and it sounds like jackhammers going off. It's very, very loud. And what they're doing is they have these basically like jackhammers compressing the nutrients really hard and pounding them into tablets. And they're super hard. I mean, we all hold tablets. And then we swallow them and we expect our stomach acid to dissolve them. Some supplement companies will evaluate the dissolution properties of a tablet. Other ones don't. And many times what happens is that tablet goes all the way through the entire digestive system and into the toilet, the same as it went through. So tablets are out. And the only time I like tablets is if, one, they're chewable, two, they're sustained release or extended release. Those are the only two times.
Gotcha.
And if you're taking antacids, you probably don't want the extended or sustained release because they won't dissolve on you. The next one would be a capsule or a gel cap. You're not going to find folate typically in gel caps. You'll find them in capsules. Capsules are great. Just look at the other ingredients and make sure they don't have a bunch of other garbage in there like food coloring or propylparabens or and so on. I don't like using magnesium stearate either in capsules. It's very fatty, and it's okay, but it's not ideal. I much rather use, say things like leucine or other amino acids that dissolve readily. The reason they put magnesium stearate in capsules is so the folate will get into the capsule well and they can close it up. The other one is a chewable. Chewables are great, as long as they're clean, without a bunch of garbage. Titanium dioxide I'm not a fan of. Lozenges can be really, really good, especially for those who are sensitive, who have digestive issues or are taking antacids, or who really want to dial in their dose, or if it's a very powerful nutrient. So I like lozenges of methylfolate and folinic acid because these are very, very powerful nutrients. So you'll feel the effect literally within minutes. So if you put the lozenge in your mouth, under your tongue or not, and you just let it dissolve. But before you do that, you pay attention. It's like, okay, how am I feeling? How's my head feeling? How's my vision? And how's my clarity of thought? Seriously, you run those questions through your head, then you put the lozenge in your mouth of folinic acid or methylfolate or methylcobalamin or a trio of thereof. Mm-hmm. And then you reevaluate after a few minutes. And you're like, wow, my vision is actually much clearer. My head is not as heavy, typically the frontal area. and the vertex of your head, the top part of your head, also will lighten up really quickly. And then you'll sit there and it's like, wow, this is actually really cool. And then you'll say, yeah, my thinking is really fast. It's really crisp right now. And that tablet's only, say, 25%, or that lozenge is only 25% dissolved. Now, 10 minutes go by and you're all excited and this is sweet. Now you're starting to get just a tinge of anxiety or a tinge of headache. That's when you take the lozenge out. Because now you've gone from foggy to wired, right? So it's like a few sips of coffee, you're good. But if you have 3 cups of coffee, you're not good. So at least
great way to test drive things then versus having a full capsule, obviously, and not being able to then control the dosage.
Exactly. So because once you swallow a capsule, it's done. And you're just kind of thinking, oh, I don't know if that's a good thing for me or not. So I love lozenges to help test or regulate the dosage. And that's really good for people. And then the other one is liposomal. And liposomal is important for people who have receptor-based problems or transport problems. And a lot of us have that. And the more I learn about transport and receptors for moving nutrients in and out of the cell, the more I realize how significant this is. And we think that when we swallow a nutrient or we eat food, we're good. The body will take care of it. And it does. Sometimes. All the time, no. And especially if you're struggling with chronic disease or you're trying to get the ultimate performance or the ultimate outcome, liposomes are needed because they will help deliver that nutrient, whatever is inside the liposome, directly into the cell without need for receptors, without needs for transport proteins. And that's beautiful because there are transport proteins that are produced by genes. And yes, genes here are also problematic. There's a folate transport gene, which is very reduced in function, down upwards of about 70%. Can be reduced, and 2 of my sons have this. And so I used the lozenges for folinic acid for him because that does seem to be okay for him. On his really off days, and maybe he has dairy because he can get dairy antibodies, and the dairy antibodies will bind to the receptors, thereby blocking the folate from getting to the cell because the dairy antibody will block to the receptor. I'm getting heavy here. The dairy antibodies. Yeah, the dairy antibodies will bind to the receptor, but folate's supposed to bind to that receptor. And the receptors are supposed to signal the cell to do something, like pull in the folate so it can do work. But it can't if there's a dairy antibody there, right? If I'm carrying 2 suitcases and you come up to me and say, "Hey, Ben, can you carry this watermelon to the kitchen?" I'm like, "No, I'm full up. I got to get rid of the suitcases first." Okay. But if receptors are full up with dairy antibodies, which is very, very common, or other antibodies, which can be elevated from homocysteine. So homocysteine is another reason to cause folate receptor antibodies, which is no one's talking about. And so liposomes can be a huge game changer for people here.
And folks with high homocysteine levels, I mean, for me, downtown Toronto, we get a lot of guys who are holding on to too much belly fat, a lot of systemic inflammation going on. Is that a client type that would potentially have that type of need assistance with the homocysteine?
Yes, for sure. And for people who are who also not eating their leafy greens or eating an inflammatory based diet, I'm sure a standard American SAD diet is like a SCD, standard Canadian diet, right?
Exactly. Yeah.
Yeah. So an inflamed person who's struggling with chronic disease, they can have tend to a higher homocysteine, but what's not talked about very often is a low homocysteine. And I just wrote an article, I think actually this week, on drbenlynch.com about low homocysteine, which is something that people don't think about. And so for me, a homocysteine lower than, I say it's 6, maybe it's 5. I just got a research paper from the library the other day to evaluate because I don't know the exact range, but I'm playing around 5 or 6. So if your homocysteine, micromoles per liter, I believe, if it's less than 5 or 6, you're going to have issues. And you have issues because homocysteine is a building block. We think of homocysteine as bad, but it's not. homocysteine, we need it. And we need homocysteine to help make our body's number one antioxidant called glutathione. And we need homocysteine to become methylated by methylfolate to become methionine to support our methylation. So if I just lost you with that, we need homocysteine to support our methylation, again, which supports your creatine, your cell membranes, your neurotransmitters, getting rid of your histamine and so on. And you need your glutathione to neutralize hydrogen peroxide and a lot of free radicals in our body, and chemicals like mercury as well, heavy metals.
That's a really great insight, because I know a lot of, or seemingly a lot of docs just seem to be focused on the high homocysteine. So we'll definitely circle back and put a link in the show notes to that article, because I'm sure a lot of the docs listening in will want to read more about that. Now, if I just circle back quickly to back to the methylfolate, you'd mentioned before people not having an effect in terms of the hair loss. What's the impact of deficiencies of methylcobalamin with the effects of the folate as well?
Beautiful question. So there's a tag team. So if you want to, I'm not a dancer, so I'm trying to get out of that, but there's what's a common dancer? You need two people to dance. What is that? Tango,
salsa, sounds good to me.
There we go, salsa. So let's spice it up with salsa dancing. So you can't really salsa dance by yourself. So methylfolate is a salsa dancer, period. It cannot do its job without methylcobalamin. So you have methylfolate, you have methylcobalamin needed to methylate homocysteine. Okay, did you get all that?
100%.
Yeah, so methylfolate plus methylcobalamin, they get together, and when they can salsa, they tear it up. That homocysteine levels drop, and they recycle, and they get the job done, and methylate gets supported. Now, if you are deficient in methylfolate, yet you have adequate methylcobalamin, what you will see on labs is you might still see an anemia. You might see a elevated MCV. You might see an elevated MCH. You might see someone who has exercise-induced asthma or is just not feeling very energetic. And then you'll get the lab, you'll also see high serum cobalamin. And their folate levels could be low if you order a serum folate. So you're like, wow, that's weird. How can I have a high B12 and a low folate? Well, because the methylcobalamin can't be used without adequate methylfolate. So you have to get the methylfolate levels up so the methylcobalamin can work. Make sense? They work in tandem. So if you're deficient in one, it's not going to work, and you're going to see high levels of MCV, MCH on your labs, or you'll see a high serum folate or a high serum cobalamin. Now, what can also be confusing, and that's called methyl trapping. So methyl trapping, because the methyl from the methylcobalamin and the methyl from the methylfolate can't get used to bind to the homocysteine and convert it back to methionine. So that methyl groups are trapped. So what you also may see is you can see a high folate and a high B12, and yet the homocysteine levels are still high. And you're thinking, well, what the heck is going on here? So methylfolate, methylcobalamin, they intersect at a very, very important juncture called methionine synthase, which is the gene called MTR. And methionine synthase, this gene, its job is to take methylfolate and methylcobalamin and homocysteine to convert it into methionine. So it does a lot of things, but it's sensitive. And what it's doing is it has a sensor built into it. It's a beautiful thing. So if someone has a lot of oxidative stress, what do you think is more important, supporting oxidative stress reduction or methylation? What do you think, Marc?
I think reducing oxidative stress would be a good place to start, no?
Right, because if someone has a tremendous amount of oxidative stress, what's the point of making cell membranes? Because those cell membranes are just going to get all oxidized and damaged, right? It's going to be a vicious cycle. You'll never get out of it. So if the methionine synthase has a built-in redox sensor and it senses the oxidative stress, then it's going to say, you know what? I'm not going to be supporting methylation right now. It's going to take that homocysteine and it's going to convert it to glutathione. And that glutathione will reduce the oxidative stress. Once the oxidative stress reduces, then the methionine synthase starts sensing, oh, you know what? Oxidative stress isn't too bad right now. And now the homocysteine can go back up and support methylation. So it's like it's train tracks where you can have, maybe the train can go to St. Petersburg or Moscow, and they're like you see in the movies where they just pull a lever and they flip the track and now the bad guy goes down the wrong way.
Yeah, for
right.
Sure.
So it's actually a really good switch right there. And so glutathione is a very, very important compound to give very early in individuals who are struggling with chronic disease. And I prefer the liposomal form, and so does the chief scientific officer of Doctors Data, David Quigg. He's seen good results. IV is also good, but IV is expensive, requires visiting a doctor. It's, you can't regulate it. You get a huge whopping dose, and there you are. You can't just take a few drops, say once a day, once a week, a few times a week. So I like the liposomal. It's as effective as the IV, and you can regulate it, and it's way, way less expensive.
Fantastic insights, and I love the analogies of sort of sensors and whatnot, rather than this common messages we get of the good and the bad in terms of the body's actions. Now, if we shift over to super physiological doses, I mean, this is something that I see in clinical practice as well. Other practitioners prescribing, 8,000, 15,000 milligrams. What's going on here? Is this needed in certain scenarios? Is this, are we just treating the smoke? Can you shed some light?
Yeah, awesome question. Thanks for asking. Yeah, you are treating the smoke. And sometimes you have to do that. Sometimes you've got to get in there and rescue the person who's stuck in the smoke before the fire's out, right? So, you have to do that at times, especially people want to feel better. So, but you should know that if you're using very, very high doses of nutrients, you should be fully aware of that there is smoke in the building and it needs to be cleared out before you go in and just know that you got to clear it out and what's causing that smoke. Common issues, and we'll talk folate here, is some doctors will say, look, you've got MTHFR, and this happens across the board. They identify that an individual has an MTHFR SNP, either 677 or 1298, or a combination of the both, and they'll immediately prescribe methylfolate. Sometimes that works, sometimes it doesn't, sometimes it backfires. So let's just say it helps, because we're talking about excessive physiological doses here. Let's say the patient takes 800 micrograms of methylfolate, and is like, doc, I didn't really feel anything. So if a person isn't really feel anything, you load them up again. Then you double it. Yeah, I got a little bit of a change, but not really. Then you give them 5 milligrams of methylfolate, and they're like, I'm starting to feel something. And then you give them 15. You bring out the big guns of Deplin, which comes in a 7.5 milligram or 15 milligram prescriptive drug. It's pretty expensive. And they're like, wow, doc, I'm not depressed. I'm full of energy. This is like, I had no idea life was this good.
Game changer.
And it's a total game changer. And then they go on and they live life amazing, and they need it every single day. They need 15 milligrams every day. And so when you have 15 milligrams of methylfolate running around your body, that's a lot. I mean, the RDA is 400 micrograms. That's more than 30 times the RDA dose. That's very super physiological.
Wow.
So then you're thinking, okay, well, why is that? No, go back to what I talked about, folate receptor antibodies. So if these individuals have high homocysteine for various reasons, say they're drinking alcohol like crazy, or they're exercising really hard, because exercising really hard will increase histamine and will increase the demand for glutathione, increase the formation of creatine, and increase the formation of phosphatidylcholine, and all these things will, kind of use up but also produce homocysteine. So if they're doing a lot of work in their body, they're still overworking, they haven't changed their lifestyle, their diet, they're still not sleeping well, they're overtraining, or eating bad food. that MTHFR gene still has to work too hard, and homocysteine is still getting screwed up. And they're also consuming dairy, and they have leaky gut. So now they have dairy antibodies circulating around. They have folate receptor antibodies. So then you have these two antibodies floating around their brain, and the antibodies are binding to the receptors, blocking the methylfolate that's in there. So now it's kind of competitive inhibition. So if you can outcompete those folate receptor antibodies with a flood of methylfolate, and you get more methylfolate in the brain versus the folate receptor antibodies, now the folate's going to have a chance, right? Now it gets a chance to dock to the receptor and get in the cell. So that's how I look at it, where they've got all these antibodies, all these things are binding to the receptors, or the receptors are few and far between for various reasons. Maybe their cell membranes aren't healthy. Maybe the receptors are downregulated, and for various reasons. Maybe they have a lot of high lipid peroxidation and the cells are just damaged and the receptors aren't fully intact and healthy, so the methylfolate can't really bind very well. So if you just flood a whole bunch of it, there's more likelihood of it to binding. Make sense? So it's kind of, you want something to happen. It's like, if you want to win the lottery, what do? You buy 100 tickets. You don't buy one.
For sure.
So, if methylfolate is trying to bind, to the receptor and there's a lot of competition, then, you need to outcompete it by taking more. So what you do is, you give them the super physiological doses, but then you work on the leaky gut. You work on lowering their homocysteine. You work on changing their lifestyle and the diet. And as you do that, mark my words, you're going to have to lower the dose of the methylfolate. If you don't, you're going to see that individual having insomnia, irritability, migraines, headaches, muscle pain, joint pain, and so on.
Yeah, another great comment and insight. Yeah, for docs there, making sure that if they are getting that initial benefit, to, like you said, as soon as they get improvement, removing some of the other roadblocks and really titrating down that dose is fantastic advice. Now, if we talk genetic testing, I'd love to get your feedback here. There's sort of the good, the mediocre, the bad in terms of genetic testing. A common scenario for me in clinic is someone gets their genetic test run, they come back with their report, and of course they have a list of anywhere from 5 to 15 different things to take to correct all these sort of problems. Can you shed some light on that first scenario? Is this an effective solution for them, or what's going on here?
You're trying to light me up, aren't you, Marc? There's a lot of SNPs in the human body. I mean, SNPs have been, again, is going back to the beginning of this podcast, SNPs have benefits, and they've been selected for because there's a benefit. And so MTHFR not working very fast, there is a benefit. At least there was in our ancestral population, and that was to fight malaria. Now we're not really in the malaria-riddled areas anymore, and we're not really eating our leafy green vegetables or our liver anymore. So now MTHFR has become a detriment to society for people who are not living healthfully or in areas of malaria. So that's we have to understand that. But we have tons of SNPs in our human body. I mean, every one of us probably has about, 40,000 to a million. That's a huge range, but we have a tremendous amount of genetic polymorphisms, every single one of us. So if you order a genetic report and you find out that you have an MTHFR SNP, you have a COMT SNP, a glutathione SNP, a norepinephrine SNP, a histamine SNP, and this report is telling you need to take 3 supplements for MTHFR, 2 for COMT, 2 for histamine. Now you're upwards of 10 supplements, and we've only talked about like 5 SNPs.
Yep.
1, it's expensive. 2, it's nonsense. And 3, it's a massive conflict of interest. So, and 4, it's just, I just pull my hair out. It just should not be done. And, what we want, all of us want, is we want the magic bullet. We want that target. And we want to be able to pick up a bow and arrow, which none of us have shot before. And we want to hit that 100-yard target right in a bullseye. I mean, we all want that. But to pick up a bow and to shoot that arrow in high winds or even moderate winds, and to get it just right in that bullseye takes practice. It takes a lot of work, and there's multiple variables there. What type of arrow we're using, what's the tension of the bow, what's the wind, what's the arc, how far away is it, all that has to be accounted for. So everything in life is multidimensional. And when there is a genetic report that says your patient has a SNP or you have a SNP, you need to take this supplement, that's a one-to-one linear relationship. And if the body was in a linear relationship, there would be no humans or life on this planet, because all the pathogens, all the heavy metals that we're faced with, all the chemicals that we faced with, these linear relationships would have been all blocked and blockaded, and all of our genes would have been struggling, and we would have been dead as a society. I mean, there would be no humans left on this planet. There is a bunch of redundancy systems built in. There's a bunch of alternate pathways. One gene will communicate to 200 like MTHFR. So even though MTHFR is one gene, it communicates to over 200 other ones indirectly. So by taking methylfolate, you're supporting the MTHFR gene, yes, but that scatters to 200 other genes. How in the hell do you know what's going to happen? You don't. By taking vitamin B6 to support a slow CBS gene, yeah, vitamin B6 is needed as a cofactor for CBS gene, but it's also a cofactor for hundreds of other genes. Magnesium, yeah, you need that for COMT, but you're also supporting 400 other enzymes at the same time. So people think that, yeah, if I swallow this nutrient, I'm going to support my COMT. Yeah, that's true, but you're supporting many, many, many others, and you cannot treat a genetic report. You have to treat the patient, because if that patient is retired, they're financially not worried at all, they are super happy, they have a fantastic community, they grow their own food, they go hunting in the wild, and they harvest their own meat, they're a picture of perfect health. And you order a genetic report, and they've got ApoE4, they got MTHFR 677 homozygous, they got COMP++, which is slowed. They have all these nasty genes, and that we think are nasty, and you're like, oh my God, you need all these supplements. Well, you order labs on these people, they're perfect. They're absolutely perfect. But yet they have all these genetic polymorphisms. Well, no, they don't need any support. They're perfect. Leave them alone. They don't need any supplementation. So you have to treat the patient. You have to understand the patient's lifestyle, their mindset, their environment, their work, what they're exposed to, the environment that they're in, their hobbies. You have to take all that into account, and their labs and the genetic report, in order to determine what supplements to give. That's how it's done properly. So all these reports, if there's a genetic report that recommends supplementation, you put it in the trash. If there's a genetic report that says these nutrients support these genes, like vitamin B2 is the cofactor, or vitamin B6 the cofactor, that's the report you want. So, and they might recommend labs, they might recommend various lifestyle changes. That's okay. But anytime they're recommending supplements, garbage.
Yeah, it's great comments, and really getting to that understanding of what the genetic test is telling you about yourself and your clinical picture is phenomenal. And if we shift gears a little bit onto the athletic side of things, there's obviously more and more testing now, whether it's nutrigenomic testing or testing to kind of predict athletic reactions to training, etc. Just curious your thoughts on any of, does that fall into a similar category? Are there certain applications to perhaps parts of those tests?
So for genetic tests for fitness and exercise?
Yeah, fitness and athletes and whatnot.
Yeah, there are. And, Craig Pickering, he's out of UK, I believe. And I was supposed to interview him last week, but my other interview prior went long. So I really wanted to wrap his brain around this, because he's very knowledgeable, one in fitness and two genetics. So you want to bring him on the show sometime.
Great.
Craig Pickering. And I think he worked for DNA Fit. And so DNA Fit is, I believe, a pretty reputable company. Alessandro Ferretti was telling me about them too. And anything that comes out of Alessandro's mouth, I pretty much trust. So he's another great person to chat with. He's phenomenal with sleep and training as well. He's like a double black belt, very fit guy. So in terms of fitness, though, I will say that, I'm not an elite athlete anymore. I was in college, and I want to be. I mean, we all want to be now, right? So I'm a weekend warrior wannabe elite athlete. But I will say that if you are training and you get red in the face, training, and it just doesn't go away. It stays 20 minutes or an hour after exercise, or you get difficulty breathing, and you're just noticing that you got to work with your breath harder and harder, and you're just kind of struggling for more air, or you get exercise-induced asthma. These are all things that have to do with methylation. Another one would be post-workout soreness. So if you're exercising, post-workout soreness is okay. Having some is normal. Now, especially if you haven't worked out in a long time. But if you're working out and you're lifting weights, and I'll get back to the methylation here in a second, is if you're working out and lifting weights, that post-workout soreness, it should be gone within, a few hours to a day, tops. Now, my wife, she has a lot of genetic polymorphisms in that SOD2 gene that I was telling you about, as superoxide dismutase. Mm-hmm. So when she would go work out, she would flare. And she loves hiking, she loves yoga, but it would take her full on a week to a week and a half to be able to go work out again. And sometimes she would just say, screw it, and want to go anyway. But then she would get progressively worse and worse and worse, and she'd have to rein it in. And she didn't want to. What happened is when you exercise, you're producing a bunch of reactive oxygen species, and you deplete your glutathione, you deplete your superoxide dismutase. So supplementing with something like PQQ, which is an amazing antioxidant, its life is like 20,000 cycles. It's vitamin E, I think, is like 4 or 5. Vitamin C is, I think, 1. So vitamin C will neutralize a free radical, and it has 1 life. It's done. PQQ can neutralize 20,000 things before it's done. So it's phenomenal. Liposomal glutathione is also phenomenal. So if you have post-workout soreness or exercise-induced asthma, you need to be considering liposomal glutathione and PQQ. Hands down, 100%.
It's a great comment. We had Dr. Tamsin Lewis on from the UK, and she's a Iron Woman UK champion, and she's mentioned that as well. So great insight there. Yeah, I'll let you keep going there, Ben. Sorry to interrupt.
Perfect. No, it's great to have confirmation on that. Thank you. And then you've got red in the face, or exercise-induced asthma, or just difficulty breathing as you're training, or excessive sweating. So if you're one of those guys playing basketball and nobody wants to guard you because you're that guy or that girl who's just a wet mop going up and down the court.
Great way to score some free points.
Yeah, right. Especially when you go for the down the lane and lift your knee up, like I used to do. But if you excessive sweating, red in the face, difficulty breathing, or exercise-induced asthma, that's high histamine, and it's also excessive adenosine. So as your ATP, we'll hit adenosine first. ATP, adenosine triphosphate. As you burn it, that phosphate becomes free and it gives you fuel. And you need water for that, by the way. So if you're dehydrated and you're exercising, you're not going to be performing as well. You need water to free the phosphate from ATP. It's a dual system. So if you're dehydrated and exercising, your performance is going to suck. So you have to be hydrated. Electrolytes are your friend. Good ones, and pure water. Now, ATP, when it's used, becomes adenosine diphosphate. And when adenosine diphosphate gets broken down, it becomes adenosine monophosphate. And now it's starting to get pretty hard by the body to convert that ADP, AMP back into ATP. And now that AMP becomes adenosine. And now you just got adenosine sticking around. And adenosine levels, the higher adenosine levels, the higher histamine will get. And histamine is a great vasodilator. That's what we have it. So when you're exercising, you want to vasodilate because you're trying to deliver oxygen to the cells, right? It's a response by the body. So, but what's happening is that adenosine levels are accumulating because your mitochondria are struggling. And your mitochondria are struggling because now your hydrogen peroxide levels are too high and your mitochondria are uncoupling. And you recouple your mitochondria by PQQ and liposomal glutathione. And you also couple them by having sufficient electrolytes and also keeping an alkaline environment, because training and exercise is very acidic. So you have to try to keep alkaline when you're doing it. So that's also another reason. So you could consider bicarbonates. Your electrolytes could be bicarbonate based. Now, that's for for that. So, and then ribose is a building block for ATP. And I'm a huge fan of ribose. Yeah, it can lower blood sugar a bit. How that does it, I don't know the mechanism of action. Maybe because it helps fuel ATP and you're burning more glucose. Maybe that's why. I don't know. But so ribose is very, very useful. I actually added ribose in my electrolytes. So the electrolytes I formulate, I've got ribose, I've got niacin to help keep the NADH-NAD ratio happy. I've got taurine because taurine is essential to balance magnesium and potassium into the cell, because without taurine, your electrolytes don't really work. Taurine is a very, very important osmotic regulator that nobody talks about. You usually don't see that. We have huge amounts of potassium because potassium is extremely important. Most people are already sufficient in sodium. And so you got to have sufficient electrolytes to help that coupling too. Now, to target directly with the histamine, so you hit the histamine indirectly by supporting with PQQ, liposomal, glutathione, and electrolytes. Now, if the histamine is still high, then that's where the methylfolate and the methylcobalamin come into play. Because histamine, intracellular histamine, which is what you get when you're exercising, increases. And in order to reduce that, it requires a gene called histamine N-methyltransferase. And that gene runs with SAMe. And SAMe is made from protein, magnesium, methylfolate, methylcobalamin. So, and you can break that histamine down by usually taking methylcobalamin and methylfolate just prior to exercise. And that is a really good way to support your genes. I almost said hack, but it's not a hack. It's just a general, I don't believe in hacking. I believe in learning how genes work. So there's a lot of information there.
Absolutely. I mean, phenomenal insights here, Ben. And, want to really respect your time. And so for the last question here, on the personal side of things, you're obviously a really busy guy. How do you start your day? What's your daily routine like?
My daily routine is I wake when I'm rested. I don't have an alarm clock. I wake very well when it's light outside. And if it's 5 a.m. and I'm awake, I'll get up. If it's 8 a.m. and I'm awake, I'll get up. I rarely am up after 8. 8 is kind of my latest, and 7:30 is kind of my usual. And then I've been working on changing my day, but now I have a really good app called Optimize. Optimize.me is the website. It's Brian Johnson stuff. And so what got me is like the word creative and reactive, the only difference is how the R's and C's are located in the word. So your creativity is most in the morning. So that's when you get your work done. So if you check your phone, that's not ideal because now you're reacting to things instead of creating. So I'm starting my day tapping into the app of Brian Johnson, Optimize Me, and no affiliation whatsoever. I just respect this guy's work immensely. And I hear what he has to say. And he's one little tips called plus ones. And so I think about what he has to say, think about how I can apply it to my life to increase my productivity and my enjoyment in life. And then I try to apply that throughout my day. Then I get up and say hi to my kids, and I evaluate how I'm feeling. If I feel that my head is full, I will go straight full in terms of like heavy and not clear, and my vision's kind of not crisp. Mm-hmm. I'll go take a shot of liposomal vitamin C and glutathione. And most mornings I will do that along with a scoop of electrolytes with filtered water. And that's pretty much my breakfast. And I won't eat until I'm hungry. And if I struggle with hunger, I'll take an acetyl L-carnitine in the morning to help burn fat. To actually, I'd be able to support those pathways, and maybe take some niacin too. And I did that today, actually. I took that exact same thing. I took glutathione, electrolytes, vitamin C, had no breakfast. I took a carnitine. And I did not eat until right before I got on your podcast. Wow. So my blood sugar dropped a little bit, which is why I was a little bit slow, probably the first 5 minutes. But my wife brought me an amazing smoothie with a bunch of great berries and nutrition in it. And then after about 10 minutes, I got my blood sugar back up and I was actually starting to think again. So sorry for that.
No, that's fantastic insights there. I mean, just the reactive nature as well is so true today in a fast-paced world where we're all just so reactive right off the jump. So phenomenal stuff, Ben. Really appreciate you taking the time. Where can people keep up with your phenomenal work? Where can people pick up your fantastic book, Dirty Genes, and stay connected with you on social media?
Yeah, thanks, Marc. So Dr. Ben Lynch, drbenlynch.com is my